Τα καταφέραμε και από το 2008 με τον νόμο 3661 που ξεκίνησε την ιστορία της ενσωμάτωσης της ευρωπαϊκής πολιτικής στη χώρα μας. Ήρθε το 2010 με την καταιγίδα αυτή των ενεργειακών κανονισμών και νόμων που έβαλε τα πράγματα σε ένα αυλάκι, σε ένα ρεάκι και νομίζω ότι τώρα τρέχουν αρκετά καλύτερα σε σχέση με τις αντιδράσεις που υπήρχαν στην αρχή. Πρόσφατα το 2010 μια μικρή αναθεώρηση.
Directives were recast, and quite recently, in February of 2013, Law 4122 has incorporated the so-called recast of Directive 31 of 2010, parts of which were already incorporated in the form of presidential circulars, or some decrees, etc. Everything is in one law. On the basis of all this, audit is asset rating. It is what we need to do. The key elements is formal conditions, that is, we do not take into account the real operation of the building, just the evaluation that is made on the basis of some values which are formally decided. Another key issue is the assessment on the basis of a simulation. And of course, number one, although last in this, is that we ignore the occupant, the user. The occupant is completely ignored. What is happening as far as the evaluation is concerned in this country? We are supposed to have started including the architectural design based on the criterion of the demand, the minimal demand. This is in gray on my slide because this is not happening. The energy design architectural design is not happening as far as the energy demand is concerned. But we evaluate the shell as far as the structural materials are concerned, and then we further evaluate the electromechanical equipment. On the basis of energy sources, so that the final energy consumption should be low, which is most important for the user who pays. Finally, we need to transform this final energy into primary energy given the fuels which we use, which is the ultimate goal that interests governments and countries which want to know the real impact of the building stock in order to decide on an energy efficiency policy so that it can comply with the Kyoto commitments. So what we do here is a rather simplified modeling of the risk and the situation. We calculate on an average monthly basis. We come to normalized estimates of consumption. Repeat, they are used as their basis, formally given data. We finally compare our estimates with the estimates again, which concern a better building, a reference building, so that we can classify the energy efficiency of our building. And at the same time, we distinguish between the usage of the bulk of the building. We don't have just one package for all buildings, because we try to evaluate reality through asset rating. A number of important things have come as a result of asset. First of all, we have a simple and satisfactory manner of assessing buildings which are not in operation, the so-called assets, especially for those who lag behind, like we do. And another important advantage is that this allows for an equivalent comparison, among buildings, which is done on an equal footing. It is fair to compare buildings on the basis of their results, but there are problems and weaknesses. Number one being that the information we get in nominal value is not credible, not in every case, but in most cases where the occupant and other parameters are quite important. And another problem is that we are unable to control, to check the occupant to make sure that they use the building properly. And more importantly, as far as the ultimate objective is concerned, we are missing it. You see a slide here on two buildings in France. This is not the average situation around the world. So gives us a picture of what we can expect in some extreme cases as far as real consumption is concerned. We have here two buildings in France which were intended to be almost zero energy consumption, so they were designed in their planning, in their materials and their layout. Nevertheless, you see the big differences, which exactly highlight what we were saying earlier, that the real situation is sometimes completely different from what the asset rating would give us. Another other data which we get from this open buildings library that this website can give us, asset ratings and reality ratings, actual situation ratings. You see the differences between office buildings and all types of buildings, and we see the CIBSE ratings, which are quite close to the actual ratings. So we see that there is quite a big difference between estimates and reality, which is the main source for this difference. Looking into it, we should come to the three reasons. Number one, that we are unable to predict accurately the systems because they are complicated, and we are using simplified models. The modelization, the asset model used is very simple, not only in Greece but everywhere. We therefore lose a big part of losses and reductions in the yields. A second reason is that what in the asset models we usually evaluate independent units and not systems which collaborate among them. I might have a distribution network which works properly and a building that is very well insulated, but how do they interact? Is there commissioning? Even if there is no commissioning, can they collaborate in an efficient manner? And finally, what is the most important characteristic of the asset rating method is we ignore the occupant, the user. And this, of course, becomes a boomerang, which is the greatest disadvantage of the method. The in buildings where the use is very important. So if we go back to the previous slides to look at the two indicative buildings, the school has much smaller, lower ventilation than planned. The children, the occupants, are actually playing with the windows, and we increase the heating loads since the automatic system does not work. This system is impacted. What is difficult to understand is the difference in the use of hot water, which is usually one of the most predictable consumptions. We don't usually expect surprises, and it is quite surprising that we get 5 times more hot water used. The only thing I can say is that something is happening there. The systems do not collaborate or are not very well regulated, although this is a very good building. And of course, the user, God knows what is happening there, how they use it, how they waste the hot water. Similar comments concerning the second building, which is an office building. Again, a very impressive difference between real consumption in heating and in ventilation. Maybe these are correlated. The higher ventilation has required higher heating loads. We are probably losing air quality, and maybe there is a differentiation in the manner that the building is used by its occupants. And since we are speaking about nearly zero energy consumption buildings, we could there has been an estimation and overcalculation of benefits from solar panels, etc., during the design. So we look at the situation, which is of course far better than any situation in Greece, but nevertheless it is a failure. 15 kilowatt hours is of course nothing compared to the 9 kilowatt hours in Greece, but nevertheless this is a failure because the target was not achieved. So the occupant, whom we have ignored to this extent, is telling us that, look, I am here, I can have an impact on all your systems, and through my interventions I can change consumption quite a bit, and somebody has to pay attention to me. If we try to analyze the occupant's behavior, we see that there is tendency for the users to do whatever is necessary to make sure that the conditions are optimal. Cooling, heating, etc. is what Nicole says that this is a very reflective behavior and not deterministic behavior as we were used to think. For this reason, in the past 10 years, we have seen more recent models which have replaced the previous models for thermal comforts, which of course cannot 100% predictable, but new parameters are now introduced in the final comfort the way we see the final comfort, and how we can say that the user is feeling well. We need to include behavioral parameters, psychological parameters, etc. So people try to shape their environment, of course, with the exception of the climate, their activities, their clothes, all this depends on the local climate, on the area that they live in. We expect different things in a taverna and in a good restaurant, in an expensive restaurant. We might expect something different from a restaurant in Mexico or in Ghana and from a restaurant in the Eiffel Tower, and even the time, the recent experience that the user has acquired is also important. If, for instance, there is a 39-degree temperature in Athens and in our house we have 32, and we are used to it, if the external temperature drops and our house has 30 degrees, we feel colder. But the opposite might also be true. All these are very important. So the new models of thermal comfort, which we use in our calculations, we have developed the different standards, which all start from the same logic. We still have the zoning concept where people feel that comfort. ASHRA provides two standards whereby they believe that people feel comfort. The European gives three comfort zones. The strictest one is 1 from here to here, while the third one is the most relaxed. Both of these tables are concerned not air conditioned but natural ventilated buildings. Later on, you will see that when you will see the ASHRA standards, you will see that they are stricter as far in cooling, while the European standard 15 to 51 is stricter as far as heating is concerned. They want to maintain high temperatures in the winter. The 15 to 51 is the one we have in the regulation in Greece, but for air-conditioned buildings. We are in category 1, whereby we need 26 to 26.5 degrees in our buildings. And another step forward, we make another step forward and we try to understand, to trace the way that occupants react to the buildings. And we can see from a study of Greek study that 67% of people say that when they open the windows that they want a better quality of air, 32% because they want better thermal comfort, and 1% do it because they want to listen to what is outside for acoustic comfort. Now, frequency, we see a great dispersion as far as when the people will open their windows in the morning, in the evening, when they leave or when they come back to the house. It is very difficult to to foresee what the user will do and how many times a day. Here you see a different analysis, trying an effort to correlate the opening and closing of windows and the interventions to the shell depending on outside or inside temperature. Another step concerning the sunning and shading, when we decide to close the blinds, depending on how much light penetration we have from the windows. And as far as natural light is concerned, and when we will turn on the light depends on the quality of daylight that we have on our working surface. You still have just 5 minutes. the user behavior can be quite unexpected, but we have a study here where we check the situation in 3 different types of model: a more modern, architecturally modern building, a more standard building, and a greener building. We see that the occupant does impact on the building with their behavior, but in the last case, the greener building, where we have tried to provide the best possible conditions, the intervention of the occupant is the smallest, and their acts have the lowest impact on energy efficiency and consumption. The same has been done in a simulating study, and we see that starting from the standard 0, we can go up to plus 89% if the users are wasteful and they're not interested in how they impact on the building, or else we can go down to minus 42% if the occupant is stricter, better, and has austerity in their minds. These are presentations of research results. This does not mean that in any building the wasteful user will give a higher consumption by 89%. For all these reasons, we see that there is a need which has been present in many years, for many years in many countries. So we now proceed to an operational rating to measure the real consumption and not the asset consumption. So keywords is we measure consumption, and we need to break down. We need to evaluate the real situation, and the occupant becomes number 1. The methodology and the manner with which we proceed in the operational rating can be very simple, especially if we have the proper equipment installed in the buildings. And we can even do this in with a remote monitoring. But while this is an advantage, because if we have the equipment, everything happens smoothly and automatically, there is a problem for the smaller buildings where this equipment is not available, and it is almost impossible to have, for instance, in this country, to have special equipment to measure the consumption, heating, cooling, etc. Another difficulty of this operational rating is that if we want to use the data independently, let's say that I have discovered that I use 1,500 kilowatt hours, and from now on I can use this in order to make further investments and policies, etc. This is okay, but if we want to compare this to a reference database, this is difficult. We do not have this reference basis, or at least a reference basis which would provide us with a credible alternative. What can we do until we do create this credible big database which will have all the schedules and the models? We can use this asset. We use the potential offered to us by the asset rating as far as the managing, operation, occupant behavior, and to more or less calibrate the results with measures which will be made on the spot on different types of buildings. The same is happening in other countries, the UK, US, etc. They are trying to build databases which will provide them with credible reference basis. There are researchers who are actually doing this to calibrate the asset data so as to calculate the operational results. We, as you see, the errors are in the smaller properties, and we also want to see what the marketplace needs. None of these two methods can be rejected because they are both useful. They have different target groups. They are both very useful and they complement one another. It is the only way for us to get credible data about our buildings. This is the attitude which prevails in the UK, where the asset certificate is available and which is valid for 10 years, as well as in other European countries, but we have the display energy certificate at the same time, which is a certificate relating to the specific building and is valid for just 1 year. On the same way, we have ASHRAE, which has introduced the building energy quotient, which is made of two things, ASHRAE asset certificate and an operational certificate. And just in order to remember how important the occupant is, if we remember the slide for the net zero building, we saw that 89% difference, 18 of which was because of the occupant, and this is not always the case. We need to remember that the occupant is always there, and in an effort to reduce energy consumption for our buildings, we change from the feasible to the what is advisable, and finally to what can be achieved. The policy that we should add should address the occupant, who can be trained and learn to impact the energy consumption from 5 to 20%. And this 20% has been circled because if the result of the study is correct and 20% can be achieved from the occupant, already we are there. So we need to start thinking that we need to have better users, better occupants. They are doing it already in Japan. Instead of telling them to buy good COP air conditionings, they tell them to live well, to eat watermelon, and to dress appropriately. Thank you very much for your attention, and thank you to those who have helped me make this presentation.
Υπάρχουν ερωτήσεις?
Any questions? Mr. Ballaras.
Μισό λεπτό να σας φέρουν λίγο. Περιμένετε λίγο για να ακουστεί η ερώτησή σας και πίσω, λίγο στο μικρόφωνο.
Θα έλεγα το εξής, οι αυτοματισμοί που βάλουν.
Well, we've introduced quite a few elements of automation. Don't they impact on the performance? Yes, they do, and that is why we are trying to incorporate automatic controls in our design, because thus we can improve or rather eliminate scope for users or occupants to intervene. When it comes to big spaces, big buildings, now this is working, and this has also helped us save energy. Yes, it's true, says Mr. Mantas. After all, it's one thing to proceed to measurements and make evaluations on the basis of measurements, and it's another to work the other way around. That's why we're trying to introduce automation controls in all buildings to make sure that the users and occupants won't mess with the systems, unlike what they do. So yes, it's useful and it's needed. in an office building where we have automated controls. In essence, occupants and users are not intervening anywhere. But in your examples, it turns out that you have certain provisions. Yes, but then again, I agree with you. And what do you attribute those examples and outcomes of yours? Is it because of the loads, the charges, and the number of occupants? Just like I said in the beginning, if we want to grasp the main reason why we are faced with these difficulties or differences, one reason may be the occupant or the user, but also other reasons such as parameters or performances, individual performances and yields for systems that we fail to realize are not interfacing or working together well. But you showed us an office space. It was an issue of heating and ventilation. Yes, but ventilation is not in the hands of the users or occupants. Well, we were trying to figure out the reasons why we were faced with such a phenomenon. We thought that maybe thermal comfort levels were low, and we thought that maybe the quality of the air was low, and so there was more ventilation, and that's why we have failed in terms of making provisions and forecasts for heating needs. I don't know who was to blame or what was wrong there. If I knew, I would have told you. Yes, but then again, we are speculating on the basis of a specific climate, but not every single winter is the same as the one before. Yes, but there's no difference of, say, 10 degrees or 15 degrees from one winter time to another, right? Pray forgive me. Another question. You told us about the high rates of, or rather how significant the involvement of the users, of the occupants may be. And you said that they impact greatly on the results. And it's true for hotels. One simple gesture or move, such as opening the door in the summer, will impact on, say, air conditioning yields. So automated controls and systems, to me, are important. Yes, I agree with you, says Mr. Mantas. Right. And the gentleman continues and says, are you evaluating those? Yes, of course. ASHRAE takes them into account and it grades them and calibrates them. And I think this is important, says the gentleman, especially for hotels. It's in public spaces because users are not paying there. Well, just like I said before, users do not influence in the same way or to the same extent all buildings. When you are dealing with a tax office and you have lots of luminaries and lots of people, the impact is different. Let us try to make sure that we will stick to the time allocated. We have two questions. I'm sure that during the break, everyone will be able to meet with everyone, and so you can get your answers in the breaks. Let's give the floor to the next speaker, possibly Mr. Mantas. How about that? It seems that someone is asking a question. Pray forgive me, says the chair. Yes, we've forgotten about that, says Mr. Mantas.
Η δικιά σας, αν θέλετε, στο διάλειμμα. Χίλια συγγνώμη.
Make sure that you ask your question during the break. Pray forgive me. Let's have just yet another. I want us to make sure that we'll stick to the time allocated, and I think we're running late. Please be brief. Say, ask your question in 20 seconds, and if Mr. Mantas can give you a reply in 40 seconds, it's okay with me. Unfortunately, the gentleman...
Αυτό δεν είναι θέμα τεχνολογίας, είναι θέμα ότι ο ιδιοκτήτης δεν θέλει να περιμένει να μπει στην κρίση που είναι η κρίση σωστή και μετά να το κάνουμε γιατί πρέπει να το νοικιάσει. Ναι. Άρα είναι νομοθεσία, δεν είναι αυτό. Αυτό όμως δεν είναι φταίει η τεχνική νομοθεσία, φταίει η ΔΕΗ που δεν παίρνει το μισθωτήριο χωρίς το προσωπικό. Εντάξει. Ναι. Θα μιλάω στο πάνω. Κώστα, ακούω την ερώτηση.
Δεν ήταν τόσο ερώτηση όσο πολύ γρήγορα, μάλλον επισήμανση. Είμαι σίγουρος ότι ο κ. Μαντάς, επειδή το είχε πει με τη θερμική άνηση και την ποιότητα εσωτερικού περιβάλλοντος, δεν συμπεριέλαβε αυτό όταν μιλάμε για την αξιολόγηση πραγματικής κατανάλωσης, ότι πέρα από όλα τα άλλα πρέπει πρώτα να έχουμε εξασφαλίσει ότι είναι και λειτουργεί σύμφωνα με τις απαιτούμενες συνθήκες, βέβαια προσωπικό θέμα.
Το θεώρησα πολύ βασικό.
Ακριβώς.
first premise on the basis of which we continue with our work, because then we talked about consumptions and comparing consumption rates next to consumption or beyond that. We know that, I guess. Everyone is aware of that. But pretty soon maybe we will be rejoicing in the fact that eventually we managed to achieve our highest goals ever in terms of energy saving for Greece. I don't know if you heard about it, but it's true. We are about to celebrate that because we will probably receive a reward or an award because Greeks have excelled. We are nearing zero energy consumption. So we are going to discuss the impact thereof. That's why I've been meaning to raise this issue. And yes, you're right. It was raised by others before briefly, but let's not forget that this, what I said before, is the main premise on the basis of which we work. And then again, since we are, we also do the same for cars. When we buy a used car, we know, or a new car, we know what sort of consumption rates to expect. And we know that our driving attitude will change consumption rates. It's the same car, but it depends on the aggressive driver or non-aggressive driver, or on the type of braking, how many brakes, how many times you'll use the brakes. But then again, each and every car, each and every engine is set to achieve certain goals, and it all depends on the handling. So, since I've embarked on this discussion, can I tell you a few things on BMS? To me, the existence of BMS alone does not suffice because everything has been examined and established and put in place. And then if you forget about that after you establish that, if you forget about the sensors and the failures, then these will be very important. We tend to forget about them. BMS alone will not suffice.